Hola a todos, soy Javier Poveda y esto es De Bien TV, el canal donde te lo vas a pasar de bien mientras aprendes geografía, historia e historia del arte. Este vídeo va dirigido a mis alumnos de primero de la ESO de sección del CEIPSO en Encinar de Torrelodones. So, in this video, we're going to take a look at the contents of the Unit 1, Planet Earth and its representation, and we're going to use the presentation we saw in class the last 2 weeks. Let's go for it with some magic. Yes, here we are. So, let me go here. Yes. So we are going to start talking about our planet, the Earth. The Earth has the shape of an almost perfect sphere, but it is slightly flattened at both the North and the South Pole. About 30% of the surface is land, continents and islands. Here, for example, we have South and North America. And the remaining 70% is covered by water, the oceans, seas, lakes and rivers. For example, here we can see the Pacific and the Atlantic Oceans. The Earth is located in the solar system. The solar system is a group of celestial bodies in which we can find, for example, a star, the Sun, which produces its own light, some planets which rotate on their axis, revolve around the Sun, and do not produce their own light. Also, we can find satellites, which are not shown in this picture because of its small size, and they revolve around some of these planets. The planets of the solar system are the following: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Also, as I said, there are several satellites revolving around some of the planets of the solar system. We only need to know the most important one, which is our satellite, the Moon. So, the solar system is located in the universe, and the universe is made up of more than 100 billion galaxies. That is, 1 with 12 zeros, galaxies. So, there are a lot. And we can classify them in 3 main types. The first type is the elliptical galaxies, which they have the shape of an ellipse. For example, this one, NGC 1132. We have also lenticular galaxies, which have the shape of a lens. For example, the Sombrero Galaxy. And finally, we have spiral galaxies. For example, the Milky Way, which is our galaxy. The solar system is located more or less at this point. This is how the Milky Way looks from the Earth. Now we have to study the Earth's movements. Just like the other planets, the Earth moves in 2 different ways: rotation, which is the movement around its axis, and revolution, which is the movement around the Sun. Let's take a look at the first. Rotation is the movement of the Earth as it turns on its own axis. The axis of the Earth is this imaginary line that goes from the North to the South Pole. It turns on its own axis once every 24 hours, so once every day. As the Earth turns on its axis during the course of the day, different parts of the planet are gradually illuminated. For example, here we have America illuminated and Europe and Africa in darkness. So this is what causes days and nights. Because of the Earth is rotating, later in the day America will be in this dark zone and Europe and Africa, for example, they will be illuminated here. We can see this in this very short video, okay? As the Earth rotates, different zones of the Earth are illuminated. And in which direction does the Earth rotate? It rotates, seen from the side, from west to east. The rotation is eastward, okay? If we look at it from the top, if we look at it from above, from the North Pole, the Earth rotates counterclockwise, okay? In this direction, the way I am pointing with my mouse. With the rotation of the Earth, we can orient ourselves. Why? Because the sun, during the day, the sun always rises on the east and sets in the west, okay? And this allows us to orient ourselves with the cardinal points. We need to know which are those cardinal points. They are four: the north, the south, the east, and the west. The second movement of the Earth is the revolution. The revolution is the movement of the Earth around the sun, creating an elliptical orbit, okay? This is not an accurate drawing, but the Earth orbit should be more or less like this, like I am doing with my mouse, okay? It takes the Earth 365 days and 6 hours to complete a revolution. So since a calendar year is 365 days, the remaining 6 hours accumulate, and every 4 years we add 1 day to the calendar in the month of February, okay? A year with 366 days, a year with a 29th of February, it's called a leap year. For example, this year, 2020, is a leap year because we had a 29th of February. And because of the Earth's axis is tilted, as you can see, it is not like this, but like this. The sun rays hit the Earth differently depending the time of the year, okay? Causing variations in temperature and the length of the day. Okay, the daylight is not the same duration in summer than in winter, for example, as you know. So, as the Earth revolves around the sun, we get different seasons: spring, summer, autumn, and winter. Okay, the main consequence of the revolution of this movement of the Earth around the sun is the succession of the seasons. And we have to know that the seasons in the northern and southern hemispheres are opposite, okay? For example, here in the north hemisphere, it's summer, but the same day, in the same month, in June, it is winter in the southern hemisphere. And now let's talk about the funny part or the interesting part of this unit, the geographic coordinates. The geographic coordinates system is a network of imaginary horizontal and vertical lines that are drawn in the globes and in the maps. These lines are called parallels, the horizontal lines. This one, for example, are called parallels, which are lines of latitude, and meridians, the vertical lines, which are lines of longitude. The parallels and meridians allows us to locate the exact position of any place in the world. Let's see how. First, let's talk about the parallels. The parallels are imaginary lines that circle the Earth parallel to the equator. The equator is this imaginary line that divides the Earth into halves, okay? And the top half, the blue part, is the northern hemisphere. I'm sorry. And the bottom half, this brown part, is the southern hemisphere. So this parallel, the equator, is the 0 degrees latitude, and we have 90 degrees of latitude to the north and 90 degrees of latitude to the south. The latitude is the angular distance from any point of the Earth to the equator, okay? And now the vertical lines, the meridians, they are imaginary lines that go from pole to pole. The most important meridian is the Greenwich meridian or prime meridian. That is this line that goes above the Greenwich Observatory in London, okay? So from this line we have 180 meridians to the west and 180 meridians to the east. So with this we can measure the longitude, which is the distance, the angular distance from any point of the Earth to the Greenwich meridian. Let's see this a bit more deeply. So we say that the latitude is the distance between any point, for example this point of the Earth, to the equator, which is this horizontal red line. The latitude ranges between 0 and 90 degrees, both north and south, and the longitude is the distance from any point on the Earth, let's take the same point as before, to the prime meridian, which is this red vertical line. The longitude ranges between 0 and 180, it's here behind the Earth, east, and also 180 west, okay? Both the latitude and longitude, as they are angular distances, are measured in degrees. And we have to use this little symbol, okay? This little circle is the symbol of the degrees. So, how do we locate a point on Earth? To locate a point on Earth, we have to take a look at the parallel, so we have to measure the latitude, and we have to take a look at the meridian, which measures the longitude, okay? In the intersection of the meridian and the parallel, so in where they cross to each other, that is the exact location, and we can measure it with its latitude and its longitude, okay? For example, point A coordinates are 50 degrees north and 100 degrees west. Here is point A. The distance from this point to the equator, the latitude, is, we look at the parallel, 50 degrees. It is north the equator, so the latitude is 50 degrees north. Now let's find out the longitude. The longitude is the distance from a point to the Greenwich meridian. So we look at the meridian of the point, which is 100 degrees, and it is located west to the Greenwich meridian. So the longitude of point A is 100 degrees west. Altogether, 50 degrees north, 100 degrees west, okay? It is important that you write first the latitude and second the longitude, okay? If you do it the other way around, it is wrong. First the latitude, the degrees, and north or south, then the longitude, the degrees, and east or west. So let's solve a couple more examples. Okay, point B, the latitude, well, the geographic coordinates are, let's see, look at this parallel, 40 degrees north, because it is north the equator, and 80 degrees east, because it is east of the prime meridian of Greenwich. Let's go to point C, this one. Let's look at the parallel. The parallel of point C is 20 degrees south, because it is south the equator. And the meridian is this, 40 degrees, so the longitude is 40 degrees west, okay, because it is west the Greenwich meridian. The geographic coordinates of point C are 20 degrees south, 40 degrees west. Let's make the last one, point D. Let's look at the latitude first. The parallel is 10 degrees, so 10 degrees south the equator, and the longitude is 20 degrees west the prime meridian. The geographic coordinates of point D are 10 degrees south, 20 degrees east. Now let's talk about the representation of Earth. The cartography is the science of studying and making maps. And the most difficult thing about making maps is how to represent the Earth sphere on a flat surface, okay, on a paper, for example. And how do we do this? With map projections. Let's look at the most important ones. A map projection is the result of projecting a 3D image, for example, the sphere of the Earth, onto a flat surface. Here you have a lot of types of mathematical map projections, but we are going to study the main three types of projections, which are cylindrical, conical, and planar. Here you have those three projections. The cylindrical projection is the result of wrapping a cylinder around the globe and then projecting the details onto the surface, okay, like this, a cylinder wrapping the Earth, and then we get a rectangular shaped map. Okay, this is the most common projection that is used in maps. Then we have a conical projection, which is the result of projecting the Earth's surface on a cone. Okay, here you see the cone like this, and you get a semicircular shape or a triangular, well, more or less triangular shaped map. Okay. Finally, a planar projection is the result of the globe, of the Earth's globe, projected onto a flat surface. Okay, so you get a circular shaped map. Just this, okay? We only need to know that the cylindrical projection results on a rectangular map, the conical projection on a semicircular map, and a planar projection into a circular map, okay? The shapes of the projections. Now, what is a map? A map is the true representation of the whole part of an area on a flat surface, okay? And of course, reduced in size. We have many types of maps. We have topographic maps that represent in detail the relief, cities, towns, and roads. For example, here you have a couple of topographic maps. And then we have thematic maps that show specific aspects of an area. We have political maps, infrastructure maps, climate maps, population maps, historical maps. Let's see some examples. This is a political world map, which shows the borders of the different states that exist on the world. This is a global relief map, which shows the main features of the Earth's relief, for example, the mountains and the rifts. Here is a historical map, which shows us different moments of history, okay? This is, for example, a historical map of the Roman Empire at its greatest extent in the year 117 AD during the reign of Trajan, okay? Trajanus. This is a demographic map which shows us the features of the population. In this case, for example, this is a map of the population density. Okay, the darkest the color, the more density or the more population density is happens in these locations. Okay, for example, in Spain, the most populated areas are Madrid, Barcelona, Valencia, etc., etc. This is a climate map which shows us different features of the climate. For example, in this one, the precipitation in Europe. The darker the green color is, the higher the precipitations are, okay, in these areas. And now let's talk about the scale of maps. The scale is the ratio, the relation between the size of the area represented on the map, for example here the United States, and the real size of the area. Okay? It can be expressed numerically and graphically. Here in this map of the United States, we have both of these scales. This is the graphic scale. This means that this distance that you can measure with your roller is in the map, it equals to 500 miles in reality. Okay? But the most important scale is the numeric scale. Why? Because it's the one we are going to use. A numeric scale is always like this. 1 divided by, I mean, a number, okay? And this means that 1 centimeter in the map equals to, in this case, 13,500,000 kilometers. So a centimeter measured in the map means that in reality, to go through that distance, the length of that distance will be, in this case, well, will be this number, okay? In this case, in this specific map, 13,500,000. Finally, time zones. Since the Earth takes 24 hours to complete one rotation on its axis, we can divide the Earth, the longitude of the Earth, in 24 strips, 24 vertical strips, and we call them time zones, okay? There is not I'm sorry. For example, right now in Spain it is 6 p.m. okay, but in Japan, for example, it is not 6 p.m. it's another time, and in America, for example, it's another time. That's why it's important to use time zones. We have on Earth 24 different time zones, okay, because the Earth takes 24 hours to rotate on its own axis, and each one covers 15 degrees of the Earth's surface, okay? And the most important time zone is the time zone 0, which is called also Greenwich Meridian Time, GMT. Okay, the Greenwich Meridian Time is the starting point for the time zones around the world. It is called GMT or also UTC, which means Coordinated Universal Time in French. Okay, so in order to find out or to know the time of the different parts of the world, starting from this time zone, the Greenwich Meridian Time, if you travel to the east, you have to add 1 hour to the time, and if you travel to the west, you have to subtract 1 hour for each time zone. Okay. In another video, we will explain how to solve map scale and time zones problems. Okay. So this is a map of the globe with all the standard time zones of the world. Okay. For example, here in Spain, look at it is colored in orange. We are in the time zone +1, in GMT +1. Okay. You can look it at the top or at the bottom of the map. The United Kingdom, here this is the Greenwich Meridian. Okay. The time zone is 0, is the GMT. Another location, for example, in New York is located in the time zone -5, Tokyo is located in the time zone +9, and so on. Okay? And this is the end of this unit. I hope you liked it. Magic again? Okay. So, this is all. As I said, there will be another video explaining how to solve problems about map scales and time zones. Espero que os haya gustado y nos vemos en el próximo. Y recordad, nunca seáis impostores. Nos vemos.